This coordinate proof problem was taken from the January 2018 Geometry Regions number 35. In this problem, you want to make sure you're taking the time to plot each point correctly. We can see here that we want to prove that triangle PAT is an isosceles triangle. To prove an isosceles triangle, you need to show that two sides are congruent. So I'm going to go ahead and do three distance formulas to show that triangle PAT is an isosceles triangle. My distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is one of the must-memorize formulas that we have. The first distance I'm going to find is going to be the measurement of length PA. So for that, I'm going to use the points P and A, the square root of -1 plus 4 squared plus -6 minus 5 squared. I'm going to enter this entire expression, the entire radicand, the part that's underneath the radical sign, into my calculator, and I end up that PA has a length of radical 130. No need to simplify. The next distance I'm going to find is that of AT. To find the distance of AT, it's going to be the square root of -4 minus 5 squared plus 5 plus 2 squared. Again, using my calculator, I'm able to find that my radicand is equal to 130. Here I've proven that both PA and AT are equal to each other. Now I am going to go the next step just to show the distance of PT to prove that it is not an equilateral triangle. So here I can take the square root of -1 minus 5 squared plus -6 plus 2 squared. For side PT, I get its distance to equal the square root of 52. Because both PA and AT are congruent, we can conclude that triangle PAT is an isosceles triangle because it contains two congruent sides, which are PA is equal to AT. The second part of this three-part question is asking us to state the coordinates of R so that quadrilateral PART is a parallelogram. There are several properties that are specific to parallelograms. The one I'm going to focus on here is to ensure that opposite sides are congruent and parallel. Now, one thing I do need to pay attention to is the order that the letters are written. I could easily create a parallelogram by plotting a third point somewhere over here, a fourth point somewhere over there. However, in labeling it, it would not be quadrilateral PART. It would be PRAT. So the order here makes a big difference. So I know that I'm going to be looking for a point somewhere in the first quadrant. In order to find this point, I want to make sure that my slopes and distances are going to be congruent to each other. So for my slope, I'm going to make sure that PT will have the same slope and the same distance as A to wherever point R is. So for this, I'm just going to simply count boxes. So I can count 1, 2, 3, 4, 5, 6 over. So from point A, I need to move 6 over. 1, 2, 3, 4, 5, 6. And then I need to move up 1, 2, 3, 4. 1, 2, 3, 4. And I can find my point R. Now take the time when counting the boxes here to make sure you get the right point. So the coordinates for point R are going to be 2, 9. For the third and final part of this problem, I need to prove that quadrilateral PART is a parallelogram. There are many ways in order to do this, and you just have to pick the way that you feel most comfortable proving and solving. You could use 4 distance formulas to show that it has 2 pairs of opposite sides congruent. You could do 4 slope formulas to show that there are 2 pairs of opposite sides parallel. In this case, because I already have used distances in the first part of the problem, I'm going to reuse those numbers. In particular, I'm going to reuse length of PT is equal to square root of 52. Since I already counted my boxes easily here, I can find my slopes of both AR and PT. So I can write that the slope of AR is equal to, again, just counting my boxes, I moved 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. Remember, slope is equal to rise over run, or change in y over change in x. So I end up with a positive slope of 4/6 for AR. For segment PT, I'm going to double check that I counted my boxes correctly and got 1, 2, 3, 4, 5, 6 for my change in x. And my change in y, 1, 2, 3, 4. Therefore, I can conclude that AR is parallel to PT because the slopes are equal. Now, once I've proved that AR and PT are going to be parallel to each other, I'm now going to go through and prove that AR is congruent to PT. Using my calculation from the first part of the problem, I already know that PT is equal to the square root of 52. I'm going to use my distance formula again to find the distance or length of segment AR. From here, I can say the square root of -4 minus 2 squared plus 5 minus 9 squared. When I simplify my radical, I do get the square root of 52. I can now state that AR is congruent to PT because they have equal lengths. For my last step, I can write my final conclusion, which is going to be that quadrilateral PART is a parallelogram because it contains one pair of opposite sides that are both congruent and parallel.